Good morning. I'm happy to see you again for this new lesson about engines. In the last section, we saw the engine thermodynamic cycle and the different energy losses. You now know that efficiency equals CO2 emissions, and you have a better understanding of the differences between diesel and gasoline engines. In this lesson, we'll see the mechanical parts of an engine. To do so, we will follow the path of the gases from the intake till the exhaust. In naturally aspirated engines, fresh air is drawn into the cylinder directly from the surrounding environment. Nowadays, most of the engines are equipped with a turbocharger, since this means the power of the engine can be considerably increased. The turbocharger increases the air pressure so a higher mass of air can be inducted by the engine for each engine cycle. In this way, a higher quantity of fuel can be burned. There are two parts in the turbocharger. First, the compressor that increases the air pressure, and on the other side, the turbine that is used to drive the compressor by using the residual energy from the exhaust gases. The compressor also increases the temperature of the air, so usually an intercooler is placed downstream of the compressor, before the point where the air enters the engine. The purpose of this is to reduce the air temperature and increase its density. The air goes then into the intake manifold, which distributes the air into each cylinder of the engine through the cylinder head. Here we need to separate diesel engines from gasoline engines. In diesel engines, the intake manifold is equipped with swirl flaps, which are used to regulate the inflow of air in order to achieve optimal combustion. The swirl movement is also given by the shape of the intake pipes inside the cylinder head. This is also called internal aerodynamics. A modern common rail system sends up to 2000 bars of injection pressure to the fuel injectors, which distribute the fuel optimally in the combustion chamber. Due to the extremely quick reaction time of the injector needles, up to 4 or 5 separate injection processes can be done per cycle. In addition to the main injection process, pre- and post-injection processes are also possible. Pre-injection moderates the acoustic hardness, what we call rattling of the combustion process. Post-injections are used specifically to raise the temperature of the exhaust gas and therefore for regeneration of the standard diesel particulate filter. These factors combine to give exact and more efficient combustion. In gasoline engines, intake pipes are shaped to create an in-cylinder air motion which favors air turbulence intensity and thus combustion speed. The injector is either placed in the intake manifold or in the cylinder head in what we call direct injection gasoline engines. Fuel injection is electronically controlled for accurate injection quantity and phasing in order to obtain a correct fuel-air mixture. When the piston approaches top dead center, the spark plug supplies the amount of energy necessary to initiate the combustion of the fuel-air mixture. The spark timing is accurately adjusted to optimize engine performances. All 4-stroke engines use poppet valves to control the gas exchange. Most of the time, there are 4 valves per cylinder, 2 for the intake air and 2 for the exhaust gas. In a 4-cylinder engine, this is called a 16-valve cylinder head. The valves are generally actuated by means of cams and return springs. The cams are placed in the camshaft. The camshaft is driven by the crankshaft via the timing belt or chain. Once combustion is completed, the exhaust gases go through the exhaust manifold. In diesel engines, a part of these gases might be reintroduced into the cylinder and mixed with the fresh air. This is called the exhaust gas recirculation or EGR system. EGR is commonly used in diesel engines to reduce NOx emissions. The gases then go through the aftertreatment devices. In gasoline engines, a three-way catalyst is sufficient to control HC, CO, and NOx emissions. In diesel engines, there are multiple after-treatment devices. A catalytic converter is used to reduce HC and CO emissions. In some cases, there is also a NOx trap or an SCR system to reduce NOx emissions. The particulate filter traps the particulate matter up to a certain load. When the particulate filter is sufficiently loaded, post-injections are activated to increase the exhaust gas temperature and regenerate the particulate filter. You can see here one of the reasons why diesel engines are more expensive compared to gasoline. The after-treatment devices are multiple and more complex. Of course, we will look at each after-treatment device in detail in a future lesson. After all these explanations, you might be wondering how the engine makes the car move. We've seen that with the crankshaft, a rotational movement is produced. If we use a very simple picture, you can imagine that the crankshaft is solidly connected to the front wheels of the car. The wheels then turn at the same speed as the engine, and this makes the car move forward. Well, in reality, the wheel shaft or the drive shaft is connected to the crankshaft via the transmission or the gearbox. The gearbox uses a clutch and a movable gear stick operated by the driver in the case of manual transmission. Each gear in the gearbox is connected to the drive shaft of the wheels. To make the car move, we need to connect the clutch from the engine to the drive shaft. The clutch is connected when the driver steps on the clutch pedal. Each gear is different in size and consequently, when selected and connected to the drive shaft, it rotates at a different speed, which increases or decreases the speed of the output shaft that is connected to the wheels. This allows the driver to select the correct gear to get more power or speed to reach the required performance for any given driving condition. We've seen now the main components of the engine and how the movement is converted to make the car move. As before, do not hesitate to listen again to any of the lessons. It would be helpful to fully understand the course. I'll see you in the next lesson. Bye for now.